Lambda is usually a fairly large number. Cp delta t is usually not nearly as big as lambda, but in any event, that's the slope. The slope is positive, so the slope, this is the slope. And so for subcooled feed, the line looks like this. So this is saturated liquid. This is subcooled. This is saturated vapor. And there's cases where you might have a two-phase feed, in which case the line's in here somewhere. There's a case where you might have superheated vapor, the line's in here somewhere. You can work those cases out, but there's one thing I wanted to do. I wanted to have this calculation make some physical sense. So let's take the case 3. Now, I guess I can remark to complete the story that in case 1, the saturated liquid feed, what you find out is V equals V prime and L equals L prime equals L plus F. In this case, you come to find out that V equals V prime plus F and L prime equals L. Let us talk about what the flows might be like in case 3, where I have cold feed coming in, and see if this thing is even trying to make any sense. So I'm going to calculate, I'm going to take that top equation over there on the far left board, and I'm going to write F equals V minus V prime, I think, minus L prime minus L minus L, V minus V prime, that's good. L minus L prime is V minus V prime times something. L minus L prime is V minus V prime times this joule right here. Lambda over H minus HF plus 1. So that's what I want to put there. Lambda over, what did I just say? H minus HF plus 1. So I'm going to write this as F equals V minus V prime times 1 minus this. That knocks out that, and this is minus lambda, well, plus lambda over HF minus H. I probably would have been better off leaving that as minus H minus HF. Now, we said over here that in the case of interest, H minus HF is Cp delta T. So I've got something that looks like this. F equals V minus V prime times, okay, what did I say here? This minus this is Cp delta T. I don't know whether I like this or not. But right now, here's what it is. Okay, so I'm probably going to like this, or I'm going to like it up to a sign. Let's see how it works out. But I can see that there's some things about it that I like. So it says F times Cp delta T. Now that's the sensible heat that the feed's carrying in below saturation. Okay, I'll divide it by lambda. This now is the well, let's finish the equation. You can see everything. There's a minus sign, so it must be V prime minus V. So I'll put the V here, I'll put the V prime here. Now, do I like that? Do I like that? I'm trying to decide if I like this. I don't like this. I don't like this. Because I would have far rather have had, did I screw this up? V prime minus V. Yeah, there's a sign wrong somewhere. I don't know whether I'll find it or.
Dr. Johns?
Let me finish. There may be there's definitely a sign wrong here. Let me tell you what I would have liked to have had.
If you tell me the chapter, I can tell you the formula.
It's tough to find sign mistakes. V prime.
You too?
Find sign mistakes.
Here's what I would have. Oh no, I love this. No sign mistake. Okay, well go ahead and ask your question now. No sign mistake.
What chapter is this in the book?
I don't know. I don't read the book. You read the book. But I will say this.
What is this called?
It's called.
Like before it was really still, what is this called?
This is called doing the simplest distillation problem that man can possibly invent. Hey, there's an interesting thing I saw today driving
Chapter
in.
5.
I don't know whether you've tried this or not, but once or twice I've had a sip of vodka.
Distillation.
We won't talk about it
Things are the
anymore
first
now,
days in
but
life.
here's what I decided when I had a sip of vodka. I
Yeah,
decided
there's a bunch of
vodka
distillations,
has
yeah.
got to be
I think it's on
pure
chapter
ethyl
5 too.
alcohol. So here's what happens. I'm driving in today and there's a truck driving by and they sell vodka. Guess what they say? 7 times distilled. That's what we're doing here. 7 times distilling vodka. So what are we trying to do with the vodka? We're trying to get all the water the hell out of it so it really is pure ethyl alcohol. Now look, pure ethyl alcohol is kind of tough on your liver, so be prepared for bad things. Look at this equation. I believe it's correct. It tells me that if I bring in some V prime here up to the feed plate and I put some cold feed in, the V going off is less. Why is the V going off less? Because you've got to condense some of the V prime to remove the sensible heat of the feed and the subcooling of the feed and bring it up to saturation. So this equation makes physical sense, and so in a certain sense, even if it's not quantitatively perfect, everything looks like it's making sense so far. So I thought we ought to at least say that. Now, I have a remark. You know, this stuff is full of remarks. One remark. This is an important remark. It's got a couple of parts to it. Add a feed plate. Well, let's look at a feed plate here. We have this stream coming off, we have this stream coming on. We have the feed coming in. We have this stream coming in, we got that stream coming off. This composition here and this composition here have to make a material balance on the top line. This composition here and this composition here have to make a material balance on the bottom line. All right? So, no matter what you think of feed plates, they look basically something like this. Here is a possible feed plate. This is the bottom line, this is the top line. There's there's a legitimate feed plate. This is the equilibrium curve out here because this and that are in equilibrium. That's a feed plate. Here's another feed plate.
These are.
That's a feed plate. Here comes the equilibrium curve.
Yeah.
One more kind of feed plate and you've seen them all. Here's a feed plate. Those are the only three possible feed plates. They all have to look something like that, one or the other of the three. Now, that's the first remark. The second remark is this. If you're doing the problem we're doing now, if you are doing our problem, you put the feed in where it'll do you the most good. You choose the feed plate. But if, on the other hand, and this is important, if the column's built, we had a column over here that was built. If the column is built and running, and the boss doesn't like what he sees and tells you to go out and make a calculation to confirm what he's seeing, and you're sitting here, and now built and running, that means I know the number of plates, here they are. I'm gonna have to, I'm gonna calculate what comes out, the column's been built. Feed might be here. Feed composition might be, on this plate might be nowhere near there, but when you do your calculation, here's the reboiler, you must put the feed where it is. So if you have a column that's built and the feed plate with your eyes you see is on plate 2, your calculation had very well better have the feed on plate 2. So if the column is built and running, and the boss says, what's it making? What's YB? What's XB? You know the number of plates, you know the feed plate. You better very well have the feed plate be 2, if that's where it looks like it is. Or if it looks like it's up there, you very well better have it be 1, 2, 3, 4, 5, 6, 7, 8. Okay? And it makes a difference because if you move the feed plate, what the column does will change. Okay, so there's a comment about feed plates. Let us start and make a calculation. Probably with that graph there. See how this goes. So now we're going to try and find, and as a matter of fact, we've already answered one of our questions. We now know, V prime, the boiling rate. So if we go down to our reboiler and have to design a heat exchanger, well, we kind of know how much vapor we have to create, and so we can go design a heat exchanger based on that. But that's not what we're interested in. We're interested in deciding how many stages it takes to do this job. These will be equilibrium stages, and yeah, should I just, yeah, I guess I should. Okay, here it is. Sometimes these things don't come out the way I want them to. Let's see. Okay, draw a line down here, slope R of R plus 1. I'll connect this up here. So I now have my material balance in the top, and I got my material balance in the bottom. put in my feed line, and I made sure they intersected at the feed line. And I got an equilibrium curve of some sort. And how do I want this to go? So I can have this work out the way I want. Okay. Let us draw a picture over here beside this for at least the first few stages. Here's the reboiler. Here comes V prime up off the reboiler. Here comes L back. So this is coming from stage 1. This is the reboiler. Here goes XB out. So when I make my first move here, I want to know what Y is in equilibrium with XB. Well, there it is right there. Now I want to know what L makes a material balance with that. Well, there it is right there. Now I want to know what Y is in equilibrium with that. Well, there it is right there. So let me notice that the labeling of that point would be YBX1, X1 YB. The labeling of this point here would be, well, I've got to make a material balance here. So this is X1 coming off of here. This is X2 coming off of here. This is Y1 rising from here. So the next time I make a material balance, okay, let me make this bigger. And we'll put labels on these for the first couple, and then we'll forget about it. Here I am looking at the bottom of the column, trying to make it look big. Here's XB, so that's a point whose X coordinate is XB. And since it's on the diagonal, it's XB, XB. Here's an equilibrium curve. When I make my first equilibrium calculation, this point here is the YB in equilibrium. This is the YB in equilibrium with the XB. Then I make my material balance, and now I have a point whose coordinate is X1. This was a point whose coordinate was YB. So this is X1 coming off plate 1. This is then Y1 coming off plate 1. So this would be Y1, and this would be X2, and so on. So this point here has coordinates X2, Y1. This point has coordinates X1, YB. This point has coordinates XB, YB. This point here must have coordinates X1, Y1, and so on. So in a certain sense, a person would say, well, yeah, this represents the equilibrium I reboil, this represents the equilibrium on my first stage, and so on and so forth. So there's a correspondence between what's going on in the column and what's taking place on this picture. So let's move along here and see how many stages it takes to do the job. And then we can make a point. So here we go. Say like that, say like that, say like that, say like that. Okay, so here I go. I'll try to find out how many stages. Well, there's my reboiler. There's my first stage. There's my second stage. There's my third stage. There's my fourth stage. There's my fifth stage. Now, I could put the feed in right here because I could go right to here and then take an equilibrium and then come back to here, take an equilibrium and come back to here. Of course, once I get on this line, I got to finish on this line and so on up here, and I tell the boss, I guess I'll remark that in these problems where stages come in integers, you don't always hit this right on.